Okay, so free body diagram um, of the beam. We'll put a force here. I'll call it force on the beam by the pin. And then there's a force here. I'll call it R. Um, then if you break this force into components, you get 70, 71, negative 70, 71. And break this force into components, you get negative 6928.2, negative 4,000, right? So then Newton's second law, um, we have F, BP, X and Y plus 70, 71, negative 70, 71 plus 0R plus negative 6928.2, negative 4,000. That's equal to zeros. And the rotational equation, I'll do this about the pin. Um, so you could set up the table for this, but I think you'll find with almost all of these beam problems, things for calculating those moments, it comes out pretty simply. You're just going to always, since these are always straight lines, um, and for the most part, the x components are going to be acting along the line of what you choose as your about point, horizontal from what you're choosing as your about point. You're just going to have moments produced by those vertical forces. So I think, writing those tables out for these beam problems and internal load problems and stuff probably won't be necessary. Um, so you got negative 0.25, that's the moment arm, times 7071. Well, the moment arm's 0.25. I guess I just pulled this negative out here. Really, the way you have to think about this is in terms of which way this would cause a rotation about what you choose as your about point. I chose this pin as my about point. So a downward force is going to make it rotate clockwise. And of course, when I do something clockwise to me, it looks counterclockwise to you, making everything more confusing. But, so I should do that. Okay, so that's negative. And then the next one, the moment produced by this reaction force, the moment arm is 0.5. It's going to produce a counterclockwise rotation. So we got 0.5 R. And then this one, a downward force, is going to produce a clockwise moment. The moment arm is 1 meter. So you get negative 1 times 4,000 equals 0. And if you solve this, tell me if you got the same thing. You get F BP vector is equal to pretty small values, negative 142.8 and negative 464.5. And then that reaction at the roller is a big value, 11,535.5. What that tells you is the way I have this set up, these would almost be balanced without this thing here. It almost just balances perfectly, You just need a little help over here at this pin to keep it from rotating, spinning. Okay, the next step is we have to figure out what the important points are. So, whoops. What are those in this case? What? Okay, the endpoints. Yep. And then what else? Yeah, right. So one is where this applied force is, and the other one is where this roller is. Okay. So how many cuts are we going to have to make? That's 4 important points. How many cuts? 3. Yep. We're just going to go in between every pair of important points. So one cut's going to represent the stuff from here to here, one from here to here, and one from here to here. Okay. So our important points are at 0, 0.25, 0.5, and 1. Okay, so now we have to do a cut. And our first cut is going to be, it's going to deal with the portion that goes from x equals 0, excuse me, to x equals 0.25. So x is in the interval from 0 to 0.25. So go ahead and work together on that. And when you're done, we'll do it up here.